You know, getting data from industrial equipment into your enterprise systems, it should be simple, right? But hey, anyone who's actually spent time on a factory floor knows it's usually this complex, brittle mess. Today, we're going to dig into a platform that's designed to untangle that whole mess for good.
So let's just start with a really direct question for you. How many of these one-off, custom connections are you juggling right now? You know the ones. The PLC that has to talk to the database, the robot arm that needs to feed the MES. Every single one of them is a point of failure, just waiting to happen. And this really brings us to the core of the problem. It's about moving from that chaos to having real control. And that starts with understanding the true cost of doing things the old way.
Okay, let's break this down, because this is where it gets crazy. The math seems simple enough. 5 devices, 4 destinations. But the reality, well, you can see it right there. It's this tangled web, an exponential trap. It's not addition, it's multiplication. 5 times 4 gives you 20 unique point-to-point integrations. Every device needs its own custom link to every single destination.
And just think for a second about what that number, 20, really means. It's not just some number on a slide. That is 20 different pieces of code you have to write, 20 potential nightmares to debug, and 20 things that can break at any moment and maybe even shut down an entire production line. It's a house of cards that's incredibly expensive and difficult to maintain.
And this is exactly where DIME comes in. It stands for Data in Motion Enterprise, and it's a platform that was literally built from the ground up to solve this exact problem, using a super smart connector-based approach instead of all that custom code.
Now, just look at the difference here. This slide nails the shift in thinking. You go from that messy multiplication, 5 times 4, to simple addition. 5 sources plus 4 destinations equals just 9 simple configurations, all managed through one central platform. The complexity just collapses.
So you're probably wondering, how does it handle all this data so efficiently? Let's pop the hood and take a look inside the engine to see how DIME gets its incredible speed. The architecture is actually beautiful in its simplicity. As you can see, data flows from left to right. It comes in from your sources, all your different devices and protocols. Then it hits the absolute heart of the engine, the central ring buffer. This thing uses a high-speed, lock-free design for passing messages, which is the secret sauce to its performance. And finally, the data is written out through the sinks to wherever it needs to go.
And the performance that this engine kicks out is, well, it's staggering. We're talking sub-millisecond latency and the power to handle over 1 million messages every single second. This isn't just about connecting things. It's about doing it at the speed your business actually operates.
Okay, so it's crazy fast. We get it. But performance is only half the battle, isn't it? What about flexibility? Let's check out how DIME connects to, well, just about anything, and does it simply.
I mean, this table alone really gives you a feel for the sheer breadth of what DIME can talk to. Just look at that industrial column. You've got everything from modern stuff like OPC UA to legacy protocols like Siemens S7 and even specific robot controllers. Then you've got all your standard messaging, databases, and web APIs. It's basically a universal translator for the factory floor and the entire enterprise.
And what that all adds up to is over 47 pre-built connector types, ready to go right out of the box. So chances are, whatever you're running, DIME already speaks its language.
And this is how simple it is to actually use them. If you look here, you can see a complete working integration, getting data from a PLC into a database, and it's defined in just 12 lines of simple YAML. You define your source, you define your sink, and that's it. No compiling, no deploying custom apps. It's just configuration.
But this model isn't just for a single machine or one production line. Oh no, it's designed to scale across your entire enterprise, from the very edge right up to the cloud.
The whole ecosystem is built in 3 tiers. Down at the edge, you've got DIME Connector, that's your boots on the ground running right on the factory floor. At the site level, DIME Horizon acts as a gateway, kind of like a site manager, bridging the gap. And then, way up in the cloud, DIME Zenith gives you that 10,000-foot view, a single pane of glass to command your entire fleet.
Now hold on, because for any IT or cybersecurity folks watching, this next point is absolutely huge. The architecture is pull-based. That means the on-site gateway always initiates the connection out to the cloud. What does that mean for you? It means you never ever have to open inbound firewall ports, which is just a massive security win.
And when we say scale, we mean it. A single Zenith instance up in the cloud can manage hundreds of those gateways, which in turn can manage thousands of individual data connectors spread across all of your global sites. That's enterprise scale.
So let's bring it all together and wrap this up by summarizing the Dime Advantage with these 8 core pillars of value.
All right, let's run through them. It's zero code. It's got sub-millisecond latency. It can run anywhere, Windows, Linux, Docker, you name it. It allows for zero downtime updates. It supports over 47 protocols right out of the box. It has smart routing capabilities, and it's fully scriptable and even chainable. I mean, it really does tick all the boxes.
Which leaves us with one last and pretty powerful question to think about. What would it actually mean for your organization, for your team, if you truly never had to write a custom data integration ever again?
And that's really the promise of Dime. Connect once, use everywhere. If you want to dive deeper, check out the documentation and see it all for yourself. Go check out the project on GitHub. Thanks so much for joining me.